cellular generations. With the announcement of the iPhone, there's a lot of confusion about what's 3G, what's 4G. A lot of these terms are imprecise, but I want to give you at least a little perspective on where they came from and where we're going with this technology and these set of technologies over the next few years. 1G, as you might guess, was the original analog cellular. And by analog, we mean the carrier was analog. We weren't sending bits over the air. We were, in fact, just sending waveforms, and primarily for voice. It turns out we could also do a limited amount of data. It didn't work very well, but it did work. And this whole technology actually sounded very good as well. One of the problems, though, is there were an awful lot of these in the world. We use something called AMPS in this country. In Europe, they had more than 8 different cellular systems, including NMT and TAX and a bunch of others. It was a mess. But there was a bigger problem, and that's what led to the development of digital cellular. Now, in digital, we're talking about sending ones and zeros over the air. And believe it or not, we did not do this in order to make voice sound better. We did it to get more bits on the air. Digital is more spectrally efficient, so we get more customers on the air, more conversations simultaneously. No real emphasis on data here either. In fact, this was rarely deployed. It was difficult to find, at least in this country, anybody doing data on 2G systems. And there were also a number of these that were completely incompatible with one another. TDMA, which was used by AT&T, GSM, which was used by T-Mobile, and then CDMA, which was used by Verizon and Sprint. And these technologies still exist to some degree, but gradually the carriers have been migrating to 3G. Now, there was an interim step on the way, something we call 2.5G, and that was simply putting packet data onto a 2G wireless network. So instead of circuit data, we used packet data, and the key technology here was called GPRS, the General Packet Radio System. Now, this could actually go, in theory, up to 171.2 kbits per second, but most users saw, say, 20 to 40 kbits per second. And again, this is still available in some markets as well. 3G, however, was a big step forward. Here we're talking about digital, but not narrowband anymore, broadband, and exclusively packet data. In fact, we have gotten throughput up to very, very high levels, 3.1 megabits per second on CDMA networks. This is the evolution of this CDMA. And in reality, a lot of users are reporting 500 to 700 kbits per second. Now, of course, your mileage will vary. Throughput is always highly variable. But we have been seeing significant advances here, including a new revision of EVDO that is being rolled out now by Sprint and Verizon. Now, instead of IS-95, this is called CDMA 2000, and again, the carriers here are Verizon and Sprint. And then the other competitors in this country, the major competitors, AT&T and T-Mobile, are using the evolution of GSM technology, which is called UMTS, Universal Mobile Telecommunication System. So those are the key carriers today. Now, the development of the iPhone 3G, the announcement of the iPhone 3G brings up a very interesting question. The first iPhone used a technology called EDGE, which stands for Enhanced Data Rates for Global Evolution, and it is in fact just an evolution of GPRS. Now, EDGE counts as a 3G technology according to the definition from the International Telecommunications Union, and they have been the arbiter of the definition of 3G for a very long time now. The general numbers that you look for in 3G were 144 kbits per second when you're moving at a fairly rapid rate, 384 kbits per second when you're moving not quite so fast, and 2 megabits per second when you're stationary or indoors. Now, the iPhone couldn't actually yield those kinds of numbers under every circumstance, but it was based on a 3G technology called EDGE. The problem is, even when the first iPhone was announced, EDGE was a relatively old technology. The replacement for it is something called HSPA, High-Speed Packet Access. Now, you may know this as HSDPA for high-speed downlink packet access or HSUPA for high-speed uplink packet access, but it's all under that same technological umbrella. And we call this 3.5G because just as we had an advance over 2G to 2.5 here that was quite notable, we had an advance over 3. And the advance over 3 is the fact that we can now go much faster than 2 megabits per second. How much faster? A lot faster. Believe it or not, HSPA is spec'd at up to 14.4 megabits per second. It's uncommon to find that kind of service anywhere in the world. 3.6 megabits per second and 7.2 are in fact becoming a relatively common phenomenon now. And the new iPhone 3G has this technology built in. You will not, in general, see those kinds of numbers. As is always the case, there's a big difference between peak and actual based on loading, your distance from the cell, the phases of the moon. Radio propagation is a fairly difficult technology to explain. But you can expect that you'll be getting 1 to 3 megabits per second, something on that order, out of these technologies going forward. But that's not the end. 4G is an entirely different animal, whereas 3G and earlier are all based on relatively conventional time division multiplex telecommunications technologies. 4G is digital, broadband, packet-based, and very importantly, all IP. In other words, we will be sending voice over IP over these networks as well. What's more, we will see very high throughput. Now, there's no formal accepted definition of 4G yet. A lot of people use greater than 100 megabits per second of raw throughput as the answer, but in general, you will not see those kinds of levels of throughput either. In fact, we're thinking right now that you can expect to see on the order of 3 to 5 megabits per second, which is actually quite astounding. We're talking about cable modem and DSL kinds of speeds into a moving device. You're driving along and you'll be able to receive and send data, hopefully not while you are driving, at those kinds of speeds. Wi-Fi, by my definition anyway, actually fits in here as well. If we deploy Wi-Fi on a metro scale and we use 802.11n, we really could see end user speeds of greater than 100 megabits per second. Regardless, the key technologies you hear about are WiMAX. Now this is funny because the ITU actually counts WiMAX as a 3G technology, even though it is in fact much faster to the end user than the 2 megabits per second. That's the formal definition there. LTE, which stands for long-term evolution. This is in fact the evolution of UMTS. And then Wi-Fi, which a lot of people would not think of as a cellular technology, but in fact it is. It supports handoffs. There's work underway now to be able to do those handoffs at fairly high motion speeds. So Wi-Fi, I think, will play a role in this as well. And of course, the ability to hand off between these different technologies could become a key element in the success of 4G going forward as well. Is there a 5G? No, we're not talking about anything like 5G at this point, but gigabit wireless will be the next big topic that will be tackled by a lot of engineers and carriers out there as well. So you can look forward to that at some point, but for now, we've got you covered. If you're looking for higher throughput, the entire history of cellular and wireless is oriented around delivering better service at higher throughput, and we're going to be looking at some really amazing numbers over the next few years. I hope this has been helpful. I'm Craig Mathias. Thanks very much for watching.